In this film we're going to look at the tensile strength of plant fibres. There are all sorts of different fibres you can use. Nettle, which has to be retted, and New Zealand flax, which is good. Here we're just using celery. It's easy to remove the fibres, which are mainly the vascular bundles and sclerenchyma. The fibres clamped between two bulldog clips on some clamps and stands, and then a weight holder weighing 10 grams is placed onto the fibre. You can see the fibre there running through the hook. Then further 10 gram weights are placed very carefully onto the weight holder. If the weights are dropped on, of course, that would cause a greater force than the actual weight itself. Up to 40 grams now. 50 grams. 60 grams. 70 grams. 80 grams, and then the fibre's broken. And here we are again. Do comparative work. We're just comparing different celery strands here, but it's possible to compare different plants. It's possible to compare plant fibres with man-made fibres such as nylon. Once we have some readings for the strength of the fibre, we then need to know its diameter, which we can do with a vernier micrometer as here, because then we can calculate the tensile strength in relation to cross-sectional area and compare it with other things. And here we go again with one more. This experiment has its problems. You may have noticed in the first two runs that we probably weren't getting the fibre breaking, it was simply pulling out of the bulldog clips. Some of these practicalities are worth knowing about because they can come up in questions. It's a good idea, as here, to use a long weight carrier because then the fall is less. It's less dangerous. That wasn't placed on very well, it fell rather than being placed on. So again, another of the problems with this practical. Same again there. So this is a piece of work quite full of difficulties, and as a general rule it's a good idea to not just know the basic technique of a core practical, but to also know some of the problems and pitfalls. These haven't always been covered in the films, so you may need to talk to your teacher to find out more about what they might be. The worksheets also include some further information on that as well as other aspects. What you're seeing here is really someone developing perhaps the best way to do this. It's the kind of thing that you would do in what we call a pilot experiment, developing the procedure ready for the main experiment. And we've got two issues here: how the weights are placed on and how the fibre is clamped. Another technique that can be used for this practical, which may be much better, is to use a piece of equipment called a Newton meter or force meter, which doesn't involve all this work with weights.